Hello, and welcome to the video portion for the Lofts lab of ME123. Today, we are going to cover lofts and domes. We saved the most interesting features for last, and loft certainly earns its place. The loft feature goes between profiles, including sketches, faces, and points, and interpolates shapes that smoothly fit between them. This can lead to some strange geometry where it smoothly transitions between an octagon and a circle, and it is often used to get organic, ergonomic shapes. Next up, the dome feature is fairly simple, but it does have some quirks that we're going to go over. Let's look at a simple loft. I'm going to start with two sketches, a 10mm octagon that's centered on the origin, and a 15mm diameter circle on a 20mm offset plane, also centered on the origin. Let's start with the absolute basics. I'm going to create a loft feature between these two sketches by first going to the Features tab and selecting the Lofted Boss Base tool right below Sweep. And then we can begin by selecting one sketch, then we select the second sketch, and we can see that it will generate our shape, lofting between the two sketch profiles that we have provided. Let's take a look at what it's done. We get these guidelines to help us determine how the loft moves. We can alter the shape by left-click dragging on these points. This process twists the intermediary profiles. Sometimes your model starts twisted, and it can be a pain to snap these guidelines into the correct position. For that, let's go over the rules that SolidWorks uses to define these guidelines. First, SolidWorks tries to connect from edge of sketch to edge of sketch. From this, we can immediately see the problem. Our octagon has 8 edges, whereas the circle only has 1. So how do we add edges onto our circle? We're going to need to use the segment tool. Let's exit out of our loft, and then go back into editing our circular sketch. From here, we're going to go up to the Tools tab, select Sketch Tools, and then pick Segment. Segment cuts a given sketch entity to a number of equal length pieces. We're lofting to an octagon, so we're going to set this value here to 8. From there, we need to make sure that we select sketch segments instead of sketch points. Sketch points just draws dots along the edge that we select, whereas sketch segments actually cuts the edge into equally sized pieces. This does, however, have a side effect, in that by selecting the circle and hitting our checkbox, we go from a fully defined sketch to an underdefined sketch. In order to fully define our sketch, we're going to need to define where exactly it is that these endpoints are. Given our octagon's orientation, this is best done by first adjusting the points to match up with the octagon sides a little better, and then applying a horizontal relation between two adjacent points. Now, when we exit our sketch and go to reapply our loft feature, we can select one edge on the octagon and the corresponding edge on the circle, which is going to match up the guidelines that it creates with the endpoints that we've now created for the circle. It is best design practice to always make sure that the number of edges match up for each loft profile. Okay, now that we've created our first loft, let's go a step further. In this case, I'm going to delete our loft, and we're going to add an additional profile. In this case, it's a square sketched an additional 20 units up from the previous offset plane with a side length of 10 units. In order to match the edge sizes between the square and our circle and octagon, we're going to need to split each edge in half, which can be done with the Split tool. While you're within a sketch, we can find the Split tool under Tools, Sketch Tools, Split Entities. This tool works a little different from Segment, primarily in that it's just going to cut any edge that we select wherever it is that we click. In order to do this, we're going to hit the Push Pin button over here to keep the tool active, orient ourselves to be able to look a little bit better on what it is that we have, and then left-click on each edge of our square to cut each one of these edges into 2 pieces. This is going to remove the equals relation that we had previously, but we're going to be re-adding those next. Now that we've split our square up to have 8 separate edges, we can go about fully defining it, in this case by adding equals relations between each of the new segments, in order to ensure that the entire thing is going to remain properly spaced. Lastly, to finish fully defining our sketch, we're going to need to apply one more equals between one of these segments and its neighbor on another side of the square. You could also use the segment tool to get similar results, but in this case I figured that it would be useful to also define the split tool. Now that we have our sketch fully defined, we can exit the sketch, go back over to Features, and select Lofted Boss Base to continue creating our loft. As you can imagine, the order that you select your loft profiles in does become relevant. If we go from top to bottom to middle, we end up with some rather strange geometry. However, if we go from top to middle to bottom, we get something that more closely approximates what you would probably expect. Let's take a look at what we can do to modify the start and end constraints while we're here. Both the start and the end have several different options that you can pick from. The important ones to remember are default, which is fairly self-explanatory, and normal to profile. Normal to profile forces the loft to remain orthogonal to the original profile, and the strength of this orthogonality can be modified using this box here. For homework assignments, if there is a specific distance that we require it to be orthogonal to, you will be given notice in one of the notes next to the drawing. But in general, you can assume the default end condition, unless told otherwise. All of the same rules also function for the end constraint, and the only real difference between them is which order it is that you went through. In this case, since we started with the square profile, the start constraint is going to modify what occurs there. However, if we were to have started with the octagonal profile, then our start constraint would define this base part. Now, there are a lot of cool tricks that we can do with lofts. Here I have 3 sketches that live on non-parallel planes. I can apply a loft from one sketch to the next, and then to the last one, to get some unique, organic-looking geometry that would be impossible to create with other tools. Now, one of the weaknesses of the loft is that it can be difficult to control. If you really want a loft to follow a specific shape, we have 2 options. The first option is to provide a lot of profiles to incrementally show how the shape changes throughout space. The second option is to use guide curves. Of course, these options can be used in tandem, allowing you to use a large number of profiles to show how the loft evolves, and then applying guide curves to show what path it should take as it travels from profile to profile. Guide curves allow you to predefine how the guidelines connect from profile to profile. You can apply multiple guide curves, and often have to use multiple if you want to produce controllable complex geometry. Here, I have an example. With lofts, you want to draw in your guide curves after you've drawn in the profiles, as they do need to connect to the profile at each end. I recommend that in this circumstance you use the Pierce relation in order to ensure that they connect the way that you want them to. In addition to that, you can only have a single guide curve per sketch. If you have multiple guide curves in the same sketch, SolidWorks can get confused and doesn't necessarily accept that the sketch is going to be a viable guide curve. As a last note with guide curves, they need to intersect exactly one edge of each of the loft's profiles. However, guide curves don't necessarily need to remain smooth. We can see the guide curve with a sharp corner can function just as well. So long as you only have a single guide curve per sketch, and all of the guide curves intersect with all of the profiles, the loft should function as expected. Let's take a look to see how these two function. When applying our lofted boss base, we go from profile to profile to profile, just as we had earlier. And now, for guide curves, we can see that when you select the arc one, SolidWorks is going to ensure that the outside of this loft follows that arc pattern, whereas if we instead were to select our sharp-edged one, we can see that the loft now follows that shape. Lastly, similar to sweeps, lofts can use centerlines as well. A centerline still needs to be attached to the first profile, but it does not need to connect with any of the edges. Oftentimes, centerlines are connected to the center points of profiles. Centerlines don't give you as much control over how the surface bends, but it does allow you to dictate the path that you want your loft to follow. To see how this modifies our resulting geometry, let's open up the loft tool one more time. We'll go from profile to profile to profile. Now under centerline, we can select this arc here. As mentioned previously, centerlines and guide curves can be used together, and in this case, the centerline adds a little bit more definition to the underside of the object. With all of this, it sounds like lofts and sweeps are fairly similar. Both can use guide curves and centerlines. How do we know which one to use? Oftentimes, it's going to come down to which one you have enough information for. Lofts are more powerful, but they do need more information, and they often require you to know multiple profiles that the loft takes on. Sweeps only need you to know one profile and the path that profile will follow, making them faster to prepare and easier to use, especially when we don't have as much information. In many cases, both are equally valid. For this course, most of the lofts we expect you to do will loft between significantly different profiles. Now, onto the dome feature. Dome is fairly simple, as it allows you to inflate almost any surface, and it is often used to add smooth end caps. This isn't always advisable, and I recommend that you consider creating the shape using a revolve first, but sometimes dome is the only option that we have. The dome feature lives up here under Insert, Features, Dome. From here, we can select any surface and input a height. Dome is unique in that it can be both an additive feature and a subtractive feature. If we hit the flip direction arrow, we can now see that it domes into the object, creating an impression. Depending on the surface that you select, dome can often have additional options. A table that describes each of these options in depth is available for reference in the relevant lab chapter. However, This does bring up a question. What if we only want to produce a dome that's part of a surface? Or what if I want to produce a loft that sticks out of a non-flat surface? What we can do there is use the split line tool. Let's do the dome first, since that's easiest. Split line is going to take a sketch that we've created and use it to cut a face into separate pieces. The split line tool lives here, under Curves, Split Line. Under our selections, we're going to use the pink box to select our sketch, and then the blue box is going to select the surface that we want the sketch to cut. The sketch is then going to be projected onto the surface, where it's used to split the surface along the projected edge. As we can see, this now gives us two surfaces to work with. We can then go back up to Insert, Features, Dome, and select this small circular surface to see what happens. We can see that the positive option creates a small nub that sticks out of the side of our object, whereas the negative option gives us a small impression. In addition to this, you can use any faces that you create using the split line feature as loft profiles. Do note, though, that this comes with the limitation that faces used as loft profiles need to be either the start or the end of the loft. This option allows us to generate lofts that come off of the surfaces of non-flat objects, such as cylinders. And it will provide us with some additional starting and ending conditions. Let's take a look. For profiles, we'll select this surface first, and then we'll select our sketch, make some slight adjustments to the guide curves so that it isn't too twisted. Now when we take a look under Start and End constraints, we can see that our Start constraints now also has tangency to face and curvature to face as options that we can use. Tangency is going to match up with the first derivative of our initial surface with a tangent length that we can define here, while curvature does pretty much the same thing with the second derivative, although occasionally it does need to be swapped. These options allow us to create lofts that smoothly flow between surfaces and solids, producing very organic looking and ergonomic type shapes. One other thing that we can use these new faces for is coloring our part. SolidWorks allows you to change the colors of your models, but you can only select one color per surface. By using the split line tool, we can selectively color pieces of a face of the object, allowing more control over what portions of the initial surface are which color. We go into more details on our assemblies lab, and further on in the advanced visualizations video. Well, with that, I believe that I've covered everything that I want to talk about for lofts and domes. These features allow for some very free-form style shapes to be produced, and this doesn't mean that you're allowed to skimp on fully defining your sketches. Always make sure that your profiles and guide curves are fully defined, and remember to stick with best modeling practices. Have a good day, and we will see you again next time.